My name is Dmytro Poplavskiy. I'm part of QtMultimedia team at Nokia, and today I will be talking about QtMultimedia. I would like to explain what Qt can give you in multimedia domain, give you some ideas how you can use Qt and multimedia in your application, and maybe receive some ideas from you as well. And I would like to start from some high-level overview of existing multimedia tools and QtMultimedia offering, and then I would like to discuss in more details Qt high and low level multimedia APIs, and then I would like to introduce new API document gallery. It's also related to multimedia. Well, in QtMultimedia, our main task is to give you access to multimedia capabilities which already exist on different platforms. We are not trying to reinvent new media frameworks like Direct Show, but give you nice, consistent, portable API to have access to many multimedia capabilities. And there is a really large range of existing multimedia tools, frameworks, libraries. And I would like to give some short overview of what we are dealing with to explain what Qt can give you in multimedia. I would like to start from high-level tools. It's some very task-specific. They are designed to do some limited set of only one task, but to do it well. And some examples of those tools are OpenMax AL API or Helix. It's for media playback and some streaming. QuickTimeKit on Mac and VLC Video LAN client. And those tools are quite easy to use. They're done to do some one task, but to do it well. And it's easier to optimize if you have one task. And examples of those areas are media playback, media stream, and maybe audio-video capture. On lower level, we can select some much more flexible media frameworks, like GStreamer on Linux or Direct Show on Windows. And those media frameworks usually allows you to build some very custom media processing graph. And they're much more flexible. They are often not as easy to use as those high-level tools because you also have more responsibility. But they are more suitable for some non-standard cases. And it's not very strict separation because most of examples could also fit to some different category, like GStreamer provides you camera bin, element or play bin for media playback, but just for review. And on lower level, we can select some building blocks like codecs, maxer, demaxer, maybe some complex tool for data releasing. And those tools are, in most cases, they're not used by application directly, but via media framework or those high-level tools. And some example, it's FMP, it's an amazing project with large set of codecs and containers support. It's highly optimized, and OpenMax IL and different codec, separate codecs. And on lower level, it's also possible to select some performance primitives to be used by codecs, for example. And another group of APIs, it's access to devices for input and output, for audio and video. And we have some examples like for primitives and OpenMax DL or Intel performance primitives. And for audio input or outputs also Xvideo for video rendering and video for Linux for video capture. Well, what Qt can offer for you to get access to all those media capabilities, or at least some of those media capabilities? And well, historically, Qt has quite limited multimedia support, and until Qt 4.4, all the support was limited by QSound. It's simply sounds, notification, beeps, and so on. And QMovie, it's playback of animated images. It was certainly not enough. So in 4.4, for none was introduced. It's KDE project. It's high-level API for media playback. It's portable API. And then in Qt 4.6, we also introduced some low-level APIs for video and audio. I will show you some information about audio. It's QAudio related classes provides you access to audio device. You can iterate audio devices, find which are suitable for input or output, open and start reading or writing raw data to audio device. It's simple, very, very low overhead classes to give you access to some underlying API on the platform you're working with. And they can be used on some simple games or when you would like to read and process audio data. And another set of APIs introduced in 4.6, it's video related classes. It's quite different from audio. They are not used directly. They're not providing you access to devices, but they give the API for like protocol for connecting producer of video frames and consumer. They allows to connect different parts together. And the main classes is abstract video buffer to describe video buffers of your media framework, or similarly it could be some hardware, OpenGL texture, or local memory frames. QVideo frame, it's some container for those video buffers with extra information like timestamp, resolution, and abstract video surface. It's abstraction for receiver of video frames. I will give you some example later in this presentation. It will be much more clear how and why it's used. Well, and with Qt Mobility release, we also introduced a new set of APIs. It's high-level APIs for different multimedia tasks. And the reason for this is that on mobile devices, we have a new range of capabilities like camera, sensors, radio, and we really like to provide you access to all those capabilities. And we also didn't want to limit only with media playback. It's very exciting to be able to capture video, audio, or photo to modify it. It gives much more possibilities. So we introduced those high-level APIs. They fit to on top of this range, and currently we support media playback and radio, audio recording, and camera APIs. And those are portable APIs. In simple case, your application will work on desktop, on different phones, on number of platforms. And some possible extensions to those APIs for future, it could be digital television or video, audio transcoding. For example, you captured your large high-definition video and you would like to send a friend part of it and make it smaller and stream it. And if you have some ideas what you would like to have, I'm very interested to hear your input. It's also important to tell what we are not trying to do. It's not a silver bullet. We're not trying to cover everything. And it's not media framework. We are still limited to those cases. We are trying to be flexible. Like, for example, for media playback, it's not necessary only to play local files. You can pass URI or even QR device and could implement some network part for non-standard protocol and play media. Or you can grab video frames out of camera or media player and process them. But it's not a complete media framework. If you have some really complex case, I would suggest you would choose a right tool and select media framework which suits the most your task. You're not expected to build some advanced non-linear video editor with those kind of APIs. And here is some overview of this QtMultimediakit. It's a new package. It's the first step of Qt modularization. It displays of what we offer and the classes I'm going to talk during this presentation. So we still have this gap for media framework and codecs, but maybe in future we will fill this with some bindings to existing media frameworks. I expect outside of QMultimediakit, but I can't promise anything. It's just plans or ideas. Well, and finally some code, how it works. I would like to start from simple example from Radio Tuner. It may be the simplest API, but it displays all the specific of those APIs quite well. It's very easy to use. You just build an instance of Radio Tuner, start it, it opens device and set frequency, set band, and or search for next channel, adjust volume, and well, that's more or less all. But how it works inside? When Radio Tuner is created, it requests system for service implementation. Usually it's plugins, media service plugins. It requests, please give me a service which provides radio. And if one of its installed plugins on this system provides you this backend, that in this case it's video for Linux implementation, it gives you this radio service. And then to have access to some, to start to change volume, the QRadio Tuner request controls. It's abstract interface for doing some task. And this is more or less complete radio QRadio Tuner, but it's also quite interesting to extend this. So for example, if radio supports data system, like radio data system, and it would be nice to provide this information replication about station name, what is playing right now. And in this case, radio service could provide some optional controls. In this, it's QMetadata reader control. And if some information about station name changes, it emits signal that I have new information, gives this to application. So it's the way how those radio services or general media services are extended. And it's possible to extend this radio service even more. For example, if radio supports not only playback to your headphones, but also can give you the audio packets, it's possible to save them and quote, and it's possible to use another system framework, the streamer, to encode and save the stream. And in this case, radio service exposes a few more controls. It's QMedia recorder control to start, record, and stop, and QAudio encoder control to specify settings like codec, bitrate, and all the codec parameters. And we also have another top-level object, QMedia recorder. It's helper class to give you access to this optional extended functionality. And this example, it's very common for all the media services. We always have some main media object which defines what we are going to do. Is it radio or tuner or camera? It requests backend for appropriate service. It's possible to have multiple services which are doing the same task. For example, have different implementation for front and back cameras if they're very different and have different capabilities. And the service part, it implements all the work. And it works with underlying system, APIs, framework, and exposes his functionality via a set of interfaces, some of this necessary, some optional, called controls. And application works only, not only, but mostly with those high-level classes, media object and helper objects. And some other example of helper objects are video outputs or maybe still image capture for camera. Well, and finally some code, how it looks. It's quite simple. We added recording for our tuner. So this simple case, it's very portable. If you don't have to specify, usually you don't have to specify something like codec or bitrate. And in this case, the backend has to choose something which appropriate on this platform. So on desktop, it can be one codec with one parameters. On mobile phone, it will choose what is most optimal for this type of service. And this platform, it's not even necessary to set output location. And the backend will choose the default location for audio recording or for radio recording on this device, and will give you this information after recording is done. So it's possible to keep it portable, but you also have access to all the settings, and if you need, you can specify codec, specify all the codec parameters, container, and so on. But it's necessary to be careful because it becomes less and less portable in this case. It's very likely that another device will not have the same codec, so those parameters will be invalid. And some balance, we also have set of presets you can specify. I would like to have high quality or lower quality for smaller files, and backend would choose appropriate codec and parameters. So it's how we try to choose this, to keep this API portable, but still give you all the access to platform-specific capabilities. And other media objects. And it's QMedia player for media playback, QAudio capture source for audio recording, and QCamera. Well, it's obvious. And in case of QMedia player, it's very similar. We try to keep it the same and consistent between those APIs, so it should be quite easy to use. And here we have another helper object, QVideoVidget. So we are setting video output to this widget and starting playback. But quite often we would like to have video not just on widget, but somewhere else. And for example, it could be graphics scene or QML, well, it's related. Or we would like to have video displayed on our OpenGL scene. For example, we could have some scene of theater with real video playing in your OpenGL. And another case, I was asked multiple times how I can access frames from camera. You find the frames to do some kind of processing, to perform, and it's possible. It's very possible. And in graphics view case, it's very simple because we have done all the work. We implemented a graphics video item, and you can use it instead of video widget. But for the rest of cases, you still need to do a bit of work, not too much. And to explain how to use it, I would like to explain first how we are using it, how QVideoVidget and video item works. So there is some example of player service on the displayed, some relevant part of controls. And we have three ways of doing video rendering. It's QVideoVidget control. It's where our player service gives video widget to application. So there will be video, and the application put it to layout. And another control is QVideo window control. When application tells, please render video to this window ID, to this geometry, to this region. And the third control we are interested in now. It's QVideo renderer control. This control allows you to allows player service to expose video frames and pass it outside. So the QVideoVidget in this case will render those frames itself. And in the case of QVideoVidget, it's possible to use any control, any of those. And usually QVideoVidget and QVideoWindow are preferred because everything is done on backend, and it's possible to optimize as much as possible the rendering performance. So backend usually knows better what is the fastest way to put video frame to screen on this device or platform. But quite often it's useful to use this QVideo render control, and graphics video item, it's this case, exactly this case. You cannot put QVideo to graphics scene. Well, you can with proxy vidget, but for video the performance will be too low. It's just not usable. Still, in some cases, it's possible to use video window control, so you can track the position of your item on viewport and put video on top, but it's very limited. It can be a good choice from performance point of view, but it's too limited to be practical. And the main control which used for graphics view is QVideo render control. It also can be used for your application to receive video frames. And have a look at this control. It's very simple. All it provides, it allows you to pass your video surface to backend. It's this video surface from low-level video classes I was talking before. So how it works? Usually we have some framework for video playback or for camera. It's using some kind of video buffers. It could be local memory video buffers, or it could be some handles to hardware accelerated video buffers and graphics memory and your video decoder chip. And we are interested to expose those video buffers outside of those framework player service. So we have video buffer. It's and video frame. It's QVideo frame, which some scene container, small container for those buffers, which provides reference counting and extra metadata like resolution, timestamps, maybe some color information. And this video frame with video buffer inside is passed to video surface with render call video surface, and graphics video item usually keeps this frame to the next paint or update call and keeps this frame unless the next one arrives. And when this video frame is discarded, that usually this video buffer automatically returns the buffer pool of player service to be reused. And it's very important that it's possible to use not only local memory frames, but it's possible to use OpenGL texture. For example, if we have hardware accelerated video decoding and have as output some kind of X11 PixMap or OpenGL texture, it's possible to pass it to the rendering part to render, and all this is done without video data leaving the graphics card. So it's possible to have really efficient video rendering on graphics view on OpenGL scene. QGraphics video item also can use video shaders to do color space transformation. So if you are rendering your video on OpenGL viewport, it will use video shaders to do color space transformation from YUV to RGB and save you CPU time. It's quite efficient. And application actually can do the same. If you would like to receive video frames instead of rendering to screen, you have to build your video surface. You have to implement supported pixel formats to return which formats you are interested to receive. You can understand. So the underlying framework will produce frames in these formats. And you also should implement render call where you are receiving these frames. It's also possible to implement start and stop to allocate resources and freeze them. But in the minimal example, if you only have to implement those two methods and pass this surface to control. So that's all. And finally, QML. We couldn't release this API without support for QML rendering. It's very simple. You have video element, you assign source and start and playback. It provides all the common controls for video playback, like you can set position, like seeking pause and pause, start, change volume. It's some random set of video properties show, but it's really easy to use, and in the case of OpenGL viewport, it's also very efficient. And we also have support for audio. I displayed another set of controls. It's possible to show duration, and this audio element will load also QMedia player, but we also providing sound effect QML element. And this sound effect, it's intended also for notification, for beeps, for, well, sound effect. It's limited to simple format like WAV files or some files which can be played directly on this platform. And it's using either those low level like video APIs, it's talking to underlying audio APIs directly without loading the full media framework. So it should be much faster. It should have much lower overhead, and it also can load this media service with special flag. Please give me the media service which can do simple sound. So it's still possible to have few implementation of media playback service. One extended with video with all the codecs and so on. Another one is simple, which is used only for beeps. Well, that's all for media playback, and I would also like to introduce a new API in QtMobility 1.1 release. It's camera API. I have been working with camera for last month, maybe half a year or year, and I'm quite proud with this API. You can expect to have all the usual controls you have with your digital camera. With this API, it's possible to take photo, record video, and adjust common camera settings, like you can change your white balance, set exposure compensation, query for current exposure parameters like shutter speed and ISO, or adjust it. It's also possible to lock white balance and start focusing, and well, it covers quite common use cases for digital cameras. And here is an example how it can be used. It's quite similar to player or radio. We are just creating QCamera instance, attaching some extra helper objects like video output, which is used for viewfinder, and QCamera image capture. We also can use QMedia recorder, the same as with radio, for recording video clips. And on shutter button half pressed, it's usually you would expect camera to start focusing and lock exposure and white balance parameters. It's search and lock. It's also possible to lock and lock individual exposure, white balance parameters. It's quite useful in some stations, and capture and unlock, that's all. So the simple case, it's also not very hard, but you still have access to all the common camera parameters. And also QML version. It's even simpler because QML element handles key events when camera shutter button half pressed and pressed if it's focused. And emits image captured and image saved signal. So you could display preview of this image and show as it's saved. And how this API can be used. Actually, I can see a few cases. The first is we need to add camera capabilities to our existing application, like contacts. So you take picture and it added to contacts directly. So when you see a person just in front of you, or maybe another example, it's some navigation application when you're walking and you're adding some points, and you can just add photo, describe this waypoint. And another cases, it's advanced photography applications, when you would like to adjust user interface for some specific photography cases. It could be panorama or time-lapse type of application or some very custom one. And for example, for panorama, you would like to at least ensure that your white balance is the same for all the frames, to lock white balance and maybe lock exposure. It's also nice to have some levels to ensure the horizon is straight line and not by waves, and some help to stitch it. Even if you are not stitching on mobile phone because it doesn't have so much power to do this with highest quality possible, it's still very useful to give some help to, for panorama stitching application to ensure that images you are putting in the just appropriate. And I would like to show an example of such simple modification for panorama. Just a second. Okay. So it's pure QML application. I will show you the default camera example. It's very simple example. It has few settings, so you can set white balance and change exposure compensation. It becomes dark. And also possible to zoom. So I would like to make it a bit more panorama friendly. So I added some level, and I will show you in a second. Oh, I hate this. So I added sensors with support. So you can be sure you will not be embarrassed that horizon is not straight. I also added the previous image, so you can match the next one. That's all. And what have I done? It's amazing how small amount of code I have to do to make this change. So I will not show you the implementation of levels. It's a set of rectangles with rotation property connected to sensors. But what I did, maybe diff fills one screen. Yes, it fits. So I changed on image captured, instead of displaying this preview and changing to preview state, I just assigning this preview source to this shifted preview image, so it's possible to match next image, and also camera level element which fills the camera element. It's also possible to improve this camera. For example, if I would like to have support not only for panorama in horizontal from left to right, but some, well, it doesn't work on projector well, some vertical images from right to left, I can move this preview. So it's for vertical images. Oh, that's all. And it was also quite simple. I only added mouse area that makes this draggable. Just a second. I added behavior on position of this preview image to make it moves smoothly and nicely, and added mouse area, which makes this preview image draggable, and some calculation about final positions. So that's all. Very simple. Actually, I found QML be so nice for expressing this camera user interface. It fits so nicely. So I encourage you to try to build some camera user interface in QML. It just fits perfectly. And well, as I told, another case for camera, it's when you would like to process video frames. So you could implement your barcode reader application or some detection of objects, or put vision to your robot. And well, it's not limited, it's up to you how to use. Well, that's all about camera. And I would also like to introduce a new API. It's not directly connected to multimedia, but it's quite related. And we already have possibility to play media files, but we still have a problem how to find them on device, how to select them. And common approach on desktop to display file dialog and let user to choose it's not very good user experience even on desktop, but it's much worse on mobile phone and embedded devices. Because, well, you don't want to show some home user blah 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 to some your grandfather. Well, maybe you would like to see as developer have full access to media file system, but for multimedia application, usually you are starting your media player. You would like to show your video files sorted that the last one comes first. So it's more likely you would like to play it. And this document gallery, it's API to find something on your device. And it's either some real documents like files or some virtual ones like albums or tags or similar. And it's quite clear how to use it. It's some media player application or the same camera you would like to show images you've taken before. Or audio player, it's completely different user interface, but it's still very useful with this. So what do we support? Currently we have backends for this API on Maemo, it's tracker backend. I suppose this backend can be used on Linux if tracker version matches. And on Symbian we have metadata system support. It's also possible to use system search services on another systems like platforms like Windows Search on Windows or Spotlight or macOS, but we don't have support yet. And how to use it? Actually, it's quite simple. In most cases, you are working with gallery request object, and you specify what you would like to find. It gives you gallery result set, which asynchronously provides you a result of your search. And we have few request types already. The most common is query request. When you select, I would like to find all the images, it's root type, starting from this directory, and add some filters. It's possible to combine filters and have quite a complex filters one. And another one is item request. You already have item ID, but you would like to have some extra information, so you don't want to call the full query. And the third type is type request, something like how many images I have on device. We also provide some convenience query model, which gives you access to result of this set and API to query and display it on view. and also QML version. So it's a very simple example. We would like to find all the images. It gives us URI, and which match this filter. So it's all JPEGs and large enough. And we are displaying those images in grid view. It's small preview images. Well, that's all about document gallery and my presentation. Any questions?
Do you have plans for adding an API for getting events when a certain device is connected or disconnected? For example, a new sound card or a new camera, or whether when I unplug my headset on a Symbian phone, that I need to get audio rerouted to the speaker and stuff like that?
Well, I don't remember. Maybe for audio we have this low level. I just have to check if we have notification about new devices. It's possible to query for devices.
It's possible, but you don't send events at the moment. And there were people filling a bug report, and it was marked as out of scope. And I think if you have an application that outputs sound, you're very likely interested also to give the user a choice which device you want to play the audio to, and you also want to be notified if there's new devices available. So for me, it's not such a sophisticated task. I think every application will need it who gives the user a choice to select an output or input device.
Well, it's generally possible to select the device, but I'm not sure it's possible right now to have notification. Thank you for suggesting. I will check. And
Hi, and just first questions. What's the difference between QtMultimedia and multimedia, which is included in the Qt basic mainstream?
Well, in Qt, we decided to have some separate package, QtMultimediakit. So currently it comes as part of QtMobility, but it's intended to be a separate packet, and it's first step in Qt modularization. So Qt already has some low-level classes, and we cannot remove from binary compatibility point of view. But well, I think you should use this Qt mobility, and maybe in future it will be released and delivered as a separate QtMultimediakit package. So currently it's synchronized with Qt mobility released and comes as part of Qt mobility.
Hi. Excuse me. Do you have any plans on supporting the sort of buttons on the headsets, the ECI headsets, like play and pause and stuff?
Well, it's a bit out of scope of this API. Ideally, Qt should support buttons on those, and Qt has play key events and pause key events. It even has, since Qt 4.7, camera and camera pause key events. So we are using those keys for this task. And in the best case, it should be done on Qt level, so all the application could benefit from those buttons, regardless they're using multimedia or not.
Yeah, okay, thanks.
So I have a question about Phonon. So why are you not using Phonon but doing a new multimedia API?
Well, it was not so easy to extend Phonon, for example, to my camera. There are few reasons. For example, we would like to be able to have multiple backends for different type of services, or even few backends for one service. And another, it was not so easy to implement backend which can follow this Phonon graph. So it's extra stress for backend development. Well, it was a few other reasons, but the main reason is that it was not so easy for us to extend Phonon for those new set of APIs. For none, it's nice API for playback, but it would be not so nice API for advanced camera, at least from what we try to do. Well, it's supported. It's done in KDE. It's a KDE project. We are maintaining our backends on our systems, and well, actually, I would like for none to use this low-level video for QML support and graphics view. It's very suitable to be included in for none. So it's supported, but it's not extended actively by us.
Is there any scanner support?
Excuse me?
Scanner support, do you have any?
Currently, we don't have. Thank you for the suggestion, but we don't have right now. Maybe we will have in future. It may fit this API.
So any further questions?
Yes.
Do you have any support for playing back QuickTime images on, QuickTime videos on a 64-bit Windows system? Because that's one of the current limitations.
Yes, we have support for on 64 Mac or Windows. Windows. Well, we're using QuickTime on Windows, and when QuickTime supports playback, I have appropriate components installed. Yes.
On the QuickTime thing, the QuickTime SDK being there, because I think they haven't yet updated it to 64-bit. So.
Yes, we are not trying to build our codecs. It's not really our task. We are relying on what is available on system. And if system can play this video, that QtMobility will use it. So we are trying to give you a simple, consistent API for media playback, which is easy to connect to other part of Qt. But we are not implementing new codecs.
Hi, have you planned to integrate SDL into your multimedia package, SDL video or something? SDL? Simple.
Yes, well, we don't have plans right now. It should be possible to use, to render to SDL, I think, with a bit of effort or using this video render control. But we don't have right now. I don't think it should be part of Qt. It can be some separate because, well, we don't have dependency on SDL and so on.
And how much faster is the new video surface against the video widget presentation with a frame buffer, for instance?
Well, it depends on platform. Video widget always uses something which is the best, because it's always possible to render to some Windows ID, Windows surface. In some cases, video item works with the same speed. And for example, if video widget uses OpenGL inside to render video frames, and the video item uses the same OpenGL to render on graphics view, it will work with the same speed. If we have software-based raster graphics view, it will work slower, because, well, we will be scaling and render frames in software. It can be usable, but it depends on platform, on how you are rendering. This video render control, it allows you to pass, to receive those frames, and how you are rendering, it's up to you. We are trying to do some optimized and hardware accelerated video render with graphics video item, and have this in when OpenGL is used. But if you are using X11 graphics system or raster on Windows, it will be slower. So we are already using this case when with accelerated video buffers. For example, on Mac, we can pass core image objects from backend to video item or to application and very efficiently render it to OpenGL or to native surface.
Do you make a commitment that you support the desktop as well as you support mobile devices with those new QtMultimediakit?
With desktop, the problem that quite often it doesn't have all the capabilities, so I cannot tell we support as well, because we don't have sensors on support or don't have this one. For media playback, yes, well, it's our main development platform. We are using desktop, Linux and Windows, Mac, and we have this commitment. For camera on desktop, we can use only webcam, which is much more limited than camera on mobile devices. And so yes, on desktop we may have camera support, but all you can do is just take one image in the current resolution or record this video.
So if you do what is possible, that's fine for me. I just feared with the move from Qt to Qt Mobility that probably I wouldn't be able to record audio on the desktop anymore.
On desktop we are trying to support what is possible. Qt Mobility, it's more about providing you this mobility features, but we are trying to support what's possible on desktop too.
So anybody else?
What's the current state release date of the QtMultimediakit? Will it be inside the mobility APIs in some weeks? Or what do I need to run your examples on my phone now?
Yes, it will be part of Qt Mobility 1.1, which is going to be released very soon. So it's not included directly in Qt, but it's part of Qt Mobility package. So I don't expect you to wait too much, but I cannot give you some exact date. We already have a beta release, and you can just get Git. It's all the sources are open. It's on Git, and you can get the current version and try it.
Okay, so thank you, Dmytro.
Thanks.